Greetings everyone and welcome to today's video on how to implement the Gale-Shapley algorithm in R. Now the Gale-Shapley algorithm is also known as the stable marriage algorithm or the deferred acceptance algorithm, but most popularly it's the algorithm that forms the basis behind the National Resident Matching Program or NRMP algorithm that matches medical students to residency programs. And this was developed by economists David Gale and Lloyd Shapley way back in 1962, although the algorithm was used much before that. And it solves the problem of creating stable pairs, stable matches between applicants and programs by ensuring that no pair would be rather match with each other than their current partner. So it essentially solves the problem of creating stable pairs among n number of applicants with m number of programs. And it tries to form a fair and efficient pair and allocation of positions of applicants to programs while respecting mutual preferences, so while respecting the program's preferences as well. And a bit of math behind going into its implementation in R. So let A denote the set of n applicants and let P denote the set of m programs, such that each applicant I has a preference list of length x and each program J has a preference list of length y. Now, to begin with, each applicant and each program initially is unmatched. So we have two lists or two sets, null sets to be specific, where all applicants and all positions are unmatched. The second step is to find out the highest ranking position of each applicant. So the way in which the Gale-Shapley algorithm works is it is an iterative process. So there are a lot of iterations for each applicant with a program list for each program, so that it runs to match, the loop runs to match each applicant to their preferred program, and the program also is matched with their preferred applicant. So the first iteration arbitrarily will be applicant number 1, and let's say applicant number 1 has ranked program number 1 the highest, so that loop is satisfied. Applicant 1 is tentatively matched to program 1, and the loop then moves to second iteration, which is matching applicant 2 to its preferred program. Say applicant 2 has a preferred program, program 4, so the program 4 has also ranked applicant 2, and then it will match program 2 to applicant 4, and this loop runs until all applicants are matched to the respective programs and there exist no unmatched applicants. However, this is not practical in reality because there will be some programs which have not ranked some applicants and there will be some applicants which have not ranked certain programs. So in this case, we need to account for these real world changes where some applicants might go unmatched. And to account for this, we need to run steps 2 and 3, where step 2 involves applicant I proposing to its highest rank program, say program J, and which hasn't rejected applicant I in its rank order list, that it hasn't excluded applicant I from its rank order list. And if it has included applicant I, then the applicant I is tentatively matched to program J, but if it has excluded applicant I, it will reject applicant I and applicant I will move on to the next program. So steps 2 and 3 are repeated in iterations so that stable pairs are created, and if there is an applicant which is matched to a program, but a second applicant wants to match to a program, but all spots are filled, but the first applicant isn't ranked highly by the program, the second applicant will replace the first applicant in the program. So we have to account for all these minutiae in the code. And so step number 4 is repeat steps 2 and 3 until no unmatched applicants remain, or applicants have exhausted a preference list and go unmatched. And so prima facie, we can see that steps 2 and 3 will require some sort of a loop to iterate over all applicants through all their programs, and we also need a few loops inside the loop to account for certain conditions. So if program J accepts or rejects the applicant, then what will happen if a certain applicant is ranked higher by a program than another applicant, then we need to remove the first applicant and then accept the second applicant. So we will need to account for all these minute details. Now, lastly, how do we denote the stability condition? intuitively you can understand, it is quite easy to understand, but if you want to write it down, then a stability condition of matching M is stable if there is no pair, let's say AI, applicant I and program J, such that both applicant I prefers program J over their current match, or program J prefers applicant I over their current match. This is the stability condition that can be written down, and this is an inverse of the same condition. So we have steps 1, 2, 3, 4 that we need to do. So before we do implement all the steps in R, we need to first create lists, just similar to how applicants create lists, that they rank order lists for programs, and programs create rank order lists for applicants. So in this example, let's take 10 applicants, for example, and each applicant has created their own rank order list. So applicant 1 has ranked program 1 the highest and program 3 the second highest. Applicant 2 has ranked program 1, 2 and 4. Applicant 3 has ranked program 2 and 3, and so on and so forth. And programs have also ranked their preferred applicants. So program 1 has ranked applicant 4, 9, 1 and 5, and so on and so forth. And each program has a limited number of spots, obviously. So in this case, program 1 has 2 spots, program 2 has 3 spots, program 3 has 4 spots, and program 4 has 2 spots. And we need to, like we mentioned, achieve the stability condition where each applicant is matched to their preferred program and each program is matched to their preferred applicant, and there exists no pair where this rule or condition is violated. So now we go on to doing the first step, that is creating empty lists or empty sets. So the first empty set will be a set where each program has all their spots empty, right? That is essentially how it starts. All programs have all their spots empty. So we create an empty list for all programs. The first step is also includes creating a list where all applicants are currently unmatched. So before matching, all applicants are technically unmatched. So they don't have a program where they are confirmed matched into. So this list has been created right here. So let's run this chunk of code and let's create a list where all applicants are unmatched. So when we print this list of unmatched applicants, we see that all applicants 1 through 10 are unmatched. Now the second thing we need to do is we need to create a system, so whether an applicant is applied or not. So this system will take into consideration whether an applicant is applied to that program or not, and ensures that an applicant doesn't apply to the same program more than once. So when we create this list will contain a list where all applicants are currently unmatched and no applicant has applied yet. So this is essentially an all false list. So applicant 1 has applied to programs 1 and 3, has ranked programs 1 and 3, has applied to both of these. But right now, while we are initializing, both of these are currently false. So applicant 1 has not yet applied to any of these programs. Similarly, applicant 2 has not applied to any of these programs, and so on and so forth. So the entire list is right now, everything is false. And once we start to run each iteration, we will begin to fill up this unmatched list, or whether an applicant is applied or not list, and replace this by true values. So if an applicant is applied or not, and this will prevent redundancy. This will prevent applicants from applying to the same program more than once during this loop. So once we have that nailed down, we are now ready to start writing the code to run our iterations. So each iteration, applicant 1 applying to programs, all of their program list till they are matched, then applicant 2 applying to their program list till they are matched, and so on and so forth for all 10 applicants. And then also satisfying the stability condition simultaneously. So the while loop allows us to achieve this. So while the length of unmatched applicants is more than 0, so while there exists at least one unmatched applicant, we are going to run this loop. So this is what is meant by this chunk of code. And essentially we want to iterate, like I've already mentioned, we want to iterate over each applicant over each program, for each applicant over each program. So when we want to iterate for each applicant, we create a for loop. So for each applicant in the list of unmatched applicants, this list of unmatched applicants, so for each applicant 1 2 3 4, we'll start by getting their preferred program list, and we check if the applicant has applied to all the programs on their preference list, and if yes, if they have applied and they still aren't matched, we mark them as unmatched and move on to the next applicant. Right now, applicant 1 still hasn't applied to any of their program in their list. Both of these are false. So this iteration, this loop continues to run to the next chunk of code. So, but if both of these are true and both of these programs don't want applicant 1, then the applicant will remain unmatched and we will move on to applicant number 2. Or if applicant number 1 has matched to any of the first program which accepts applicant number 1, then this will be satisfied and we will move on to applicant number 2. So in this case, let's move on. And if the applicant hasn't applied to all programs, so if one of these two is false, so this will likely be the second one, or if one of these false of applicant number 2's list is false, so either second, third are false, or only third is false, or all three are false, then this loop will continue to run. And basically, when the program also has applicant number 1 in its preference, then we will mark it as true, so that applicant has applied to program number 1, for example. And then this applicant applied list will have the first program to be converted to true. So we now know that the loop now knows essentially that applicant 1 has applied to program 1. So if it iterates over the next loop, so program number, the second program that applicant has applied to, then it knows that this is already true, so it won't check for the first program again. So this removes redundancy, like I mentioned. Right. So if the program hasn't ranked the applicant, then their application is rejected. So if the applicant applies to program 1, but program 1 has not ranked applicant 1, then they are rejected from the application, and then applicant number 1 moves on to the second program. But if the program has ranked the applicant, then we will check if the program has available spots for the applicant. So for the first iteration, it does not matter because the program will have spots. So applicant number 1 will tentatively match to its first program, provided the program has ranked applicant number 1. But if the program is full, if we are midway into the loop, and if the program is full, then we need to see whether any of the applicants that have tentatively matched into the program are ranked lower in the list than the currently applying applicant, so that they would be replaced. So we want to check this. We want to check if spots are available, and if spots are available, then the applicant is matched, and we'll remove the applicant from the list of unmatched applicants, so the applicant is tentatively matched. Or if the program is full, then the applicant is only considered if they are more preferred, like I mentioned. So if any one of the applicant is ranked lower than the current applicant, then they are removed, and the new current applicant is matched into that program, tentatively matched. And so we run this line of code, if else function, to run this line of code. So in the else function, else loop, we see whether there is some least preferred applicant as compared to the current applicant, and if there is, then we get this line that some applicant is least preferred, and then we add in the new applicant. So the new applicant is tentatively matched, and the least preferred applicant becomes unmatched and then needs to apply again. So the loop then will run for this newly unmatched applicant, then will run again. And this loop runs over and over till all unmatched applicants have a stable pair. But this loop will keep on running, because if you see this condition, while the length of unmatched applicants is more than 0, this loop will continue to run, and so it should be at least 1. But there can be situations where an applicant will remain unmatched, and no program essentially has ranked the applicant high enough for them to be ranked, and the applicant also hasn't ranked programs which are willing to take it, and has only ranked programs that are not willing to take it. So no stable match can occur. So in this case, we need to create a condition to break the loop, because we don't want an infinite loop, because that just will, as the name suggests, keep running the loop infinite number of times, because it wants the applicant to match, but the applicant clearly cannot match. So we want to break this redundant loop. So we create this if function, if loop, and we break the loop. No further matching is possible and exiting loop. So we add this line of code. And essentially, this is how the Gale-Shapley algorithm works. And now comes the moment all of us are waiting for. Let's run this loop to see how it has run. So we see all these iterations. So a lot of iterations have been run to create stable pairs. So the first iteration, applicant 1 was trying to apply to program 1. So we can see applicant 1 has program 1 in its preferred list. Program 1 also has applicant 1 in its rank order list. So applicant 1 in the first iteration will match. So applicant 1 is applying to program 1. Applicant 1 was matched to program 1. Now applicant 1 has been removed from the unmatched list. Now from the unmatched, so now this loop runs for the second time. So the length of unmatched applicant is still more than 0. It is 9 now. From an initial list of 10, 1 to 10, it is now 9 because applicant 1 was removed because applicant 1 has been matched. So now applicant 2 is applying to program 1 because it also has program 1 in its list, in its first most preferred list. So applicant 2 is trying to apply to program 1, but program 1 has not even ranked applicant number 2 and the application has been rejected. So the applicant 2 has still remained in the unmatched list. Now the loop runs to try to match applicant number 3 to its most preferred program. So you can see when people mean by saying the NRMP is, or the Gale-Shapley algorithm tries to match applicants to their preferred programs, you see how the applicant first proposes to a program and then the program can accept or reject the application, right? So applicant number 3 is now trying to apply to its most preferred program. So applicant number 3's most preferred program is program number 2, and program number 2 has not even ranked applicant number 3. So applicant number 3 will go unmatched. So program 2 does not rank applicant number 3, application rejected. Now applicant number 4 tries to apply to its most preferred program, program 1. Program 1 has empty slots left and applicant 4 has been matched to program 1. Applicant 5 is now trying to match to its most preferred program, so on and so forth. It has matched, and so on and so forth. Now what happens is program 1, its list has been filled. The number of slots, applicant 1 and applicant 2 have both tentatively matched to program 1. But now applicant number 9 also has program 1 as its most preferred list. Now program 1 spots are filled. So we want to now find what the program's preference is so that a stable pair is created. And in program 1's list, we can see the list goes applicant 4, 9, 1 and 5. And right now 1 and 2 have matched and its list is 4, 9, 1 and 5. So 1 is less than 9 in program 1's rank order list. So applicant 1, so we see that least preferred in program 1 is applicant 1, and applicant 1 has been replaced by applicant 9 in program 1, and now applicant 1 has now re-entered the unmatched applicants pool again. Now applicant 10 is now applying to its most preferred program, has matched, and this loop runs. As you can see, applicant 1 is now, because applicant 1 is still in the unmatched pool, and this while loop will continue to run till the number of unmatched applicants is more than 0, that's at least 1. It will still continue to run till applicant 1 will match, or till applicant 1 has matched to a program. But applicant 1, as it so happens, will not be able to unfortunately match to any program, and so this list would have continued to run infinite number of times had we not included this last argument or condition to exit the loop. So apparently applicant number 6 and applicant number 1 have applied to all programs, but they remain unmatched. So let's see the final matches and let's see the unmatched applicants. So we see that program 1, 2 spots have been filled by stable matches. So applicants 4 and 9 preferred program 1, and program 1 also preferred applicants 4 and 9. Program number 2, however, 3 spots were there, but only 2 have been filled to create stable conditions. Program number 3, 4 spots were there, but only 2 spots have been filled. 2 are still vacant, and program number 4 has filled all spots. So programs 2 and 3 will likely go on to SOAP to fill in the remaining spots, and unfortunately for applicants 1 and 6, they have remained unmatched. So let's try to play around by selecting by by modifying this list. Let's say program 2 wants applicant number 6. Applicant number 6 also wants program 2. Let's say program number 6 2 wants applicant number 6, and we remove applicant number 2 from this list. Absolutely. So let's run the entire chunk of code again. So applicant number 1 and 2 are now unmatched. Applicant 6 has matched to program 2, and unfortunately applicant 2 has remained unmatched. And let's also create one more change where applicant 1 tries to apply to, let's say, or let's say applicant 4 tries to apply to program 4, and let's run this list. And now right now program, like all programs have a few applicants. Only applicant 2 has remained unmatched, and applicant 1 has matched to program 1. So good for applicant 1, unfortunate for applicant number 2. So this is how you can create a Gale-Shapley algorithm in R and try to play around with this in R. And this is essentially what goes on in the background during the NRMP. And for those who have applied for residency this cycle, I wish you all the best. And hopefully this video tries to provide a source of entertainment or provides some sort of insight while you create your rank order list. And thanks for watching, and have a great day.